Alright, now let's just look into the 8th question of this paper, and this paper states that first two terms are the non-zero terms in the Maclaurin series, so sine of x square. So what we will be doing is we'll be utilizing the sine Maclaurin series for the sine of x that's already there in the formula booklet. So the Maclaurin series for the sine of x is given as sine of x is equal to x minus x cube divided by 3 factorial. And then we have x to the power of 5 divided by 5 factorial, right? So this is what we have. Now what we will be doing is in place of x, wherever we find x, we will just be substituting that x with that of x square, right? So this become x squared, and then in place of x, I will be writing x square, and then there is a power 3 in the numerator divided by a 3 factorial. And then I have plus x squared to the power of 5 divided by a 5 factorial. Now because he wanted us to write the first two non-zero terms, so I will just stick to the first two non-zero term, and I end up getting x squared minus x to the power of 6 divided by 3 factorial. So this becomes a 6, and we have that as sine of x squared. So this is the solution for A1, right? Now let's just go for the A2 and see what can we do over there. So for A2, he wants us to write the solution for sine squared of x squared. So I can write this as sine of x squared whole square, right? So I have the expansion of sine of x squared with me, which is given as x squared minus x to the power of 6 divided by 6. By the way, if this question come in exam, I would advise you to write dot 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 so that they understand that this sequence is just having an expansion. Similarly, I'll multiply that with x square minus x to the power of 6 divided by a 6, and then dot dot dot. So now when I multiply these two, I end up getting x squared times of an x square. So yeah, that is going to be the first term that I'll have. Then I multiply x squared with that of x to the power of 6 divided by a 6, and then from this one, when I multiply this with this thing, I end up getting x to the power of 6 divided by 6 multiplied by an x squared. So yeah, this is what I get, and ultimately I have that as x to the power of 4 minus x to the power of 8 divided by 6 minus x to the power of 8 divided by a 6, which is going to be x to the power of 4 minus 2x to the power of 8 divided by a 6, and I can write that as x to the power of 4 minus x to the power of 8 divided by a 3 up to so on, this much of the term. So this is the expansion for sine of x squared whole squared. So yeah, this is what I get, right? Now in the next part, we are supposed to find out the value for 4x sine of x squared. So we just need to find out the value for 4x sine of x squared into cos of x squared, right? This is what we are supposed to find out in the part B. So in order to find out that value, we have again the first two non-zero terms we need to find out. So what we can do is we need to think about our previous solutions, right? Because what happens is sometimes the answer is hidden actually back there, right? So if we utilize the previous solution, I think we can get to the point, and let's just look into that. How can we do that? So if I differentiate d by dx for sine of x squared to the power of 2, right? So what that would look like is you can utilize the chain rule. I'm doing that directly. So this is 2, right? The power comes down, and then I have this as sine of x squared to the power of 2 minus 1, which is going to be 1. So I'm not going to write that up here. And then sine of x squared, which is going to be cosine of x squared. I'll multiply that, and for the x squared, the derivative is going to be 2x, right? So this is going to be 4x sine of x squared times of the cosine of x squared, right? So this means that if we take the derivative of this function, which is sine of x squared to the power of 2, I'll end up getting this thing, right? This means something else as well. And what is that? That if we differentiate the right hand side of the solution that we derive in a part 2, we will get the derivative of this thing, right? So now let's just look into the d by dx of x to the power of 4 minus x to the power of 8 divided by a 3 and up to so on, right? So if we differentiate that, so this becomes 4x cubed minus 8x to the power of 7 divided by a 3 up to so on, because they wanted us to find out for the first two non-zero term. So this is equal to the derivative of sine of x squared, sine squared of x square. So yeah, this is equal to what our desired result is. So yeah, this is going to be our solution.